seeing a lot of entertainment. So the next paper is presented by my student, Matt, um, titled Sounds of Health Using Personalized Sonification Models to Communicate Health Information.
Awesome. So I'm Matt. I'm a third-year PhD student at the University of Virginia. I'm going to start off my presentation by actually asking all of you a question. As a warning to those in the audience, there's a lot of music in this presentation, so if you're sitting by a speaker and don't want that, I'm sorry. Anyway, so I'm going to play two short melodies for you here, and I want you to imagine that they're representing your health information. I want you to think about which of these two would you rather be representing something that's healthy. All right, so by a show of hands, who would prefer hearing the first one when it's trying to represent something that's healthy? All right, so as I'm sure you're getting the impression looking around, there's a very strong preference towards the second option. And as we're going to show here in a little bit, that's actually not that surprising. So a little bit of introduction on our work here. It's building off the idea of ambient displays. So whether or not we can ambient displays present health information using metaphors. Typically, these are done using vision, and usually an app that shows something like a garden or an aquarium that gets more active or grows as you're more active. But these existing approaches all rely on vision. Meanwhile, another field of sonification works to embed data into sounds. And that has been used in behavior interventions, but those are almost all in-the-moment interventions, such as in physical therapy, changing the tone of a note when you raise your arm. Our research seeks to combine these two ideas, investigating whether or not we can encourage healthier behavior using music as a display. In this specific work, we're trying to figure out the very basic question of, is this even possible? Given the fact that everyone has different music tastes, and how can we account for this in these systems? So we developed an approach to embed health data into music. It's all based on the underlying assumption that if we take a melody and adjust it in specific ways, it will change how healthy the user perceives it to be. We created 3 types of alterations, the first one being altering basic music features within the song. I'll get into more detail about what these are in a few slides, but these are things like adjusting how fast the song is, or as we heard, the pitch. We can also adjust the instrument the song is played on, or the number of melodic lines within the song, essentially adjusting the complexity of the song. We developed a study where participants did 2 surveys. In these surveys, participants listened to musical features and the adjustments, and basically rated them on a 5-point Likert scale from not well at all to very well. The first survey was the same for everyone. They listened to 1 change at a time and rate it. The second one was developed using personalized models for each user based off their responses to the first one. So combining the 5 different musical features that we're looking at. We recruited 55 participants for this study. There were 52 included in the analysis for the first survey and 45 in the second. So, as promised, here's more music. So, our very first question was, does altering the musical features in the song change the perceived wellness of the melody? I'll go over what they are, but as a baseline song with no real alterations so you can get the idea of the changes, here's a C major scale. So the first change that we could do is adjusting the tempo or the speed of the song. For the sake of time, I'm not going to let long ones play in their entirety, but here's a snippet of it. So as you can see, that one's a lot slower now. We can also adjust the pitch, making the song higher or lower. We can adjust the dynamic, making it louder or quieter. We can adjust it to a minor key. For music people, that means we adjust some of the notes slightly. For non-music people, essentially means we're adjusting how happy the song sounds. And lastly, we can adjust the smoothness of the song, making the notes staccato so there's more space between them. So what we found was participants' perceptions followed trends, similar to what we saw here. Specifically, tempo, pitch, and key all followed very clear and distinct trends between our users. For tempo, the faster the song, the healthier it was perceived. So a slow melody, like this one, was perceived less healthy than a faster melody like this. Meanwhile, for pitch, we also found that, generally speaking, higher pitches were perceived as healthier. The outlier being the highest option, where some participants thought that was the healthiest, while other ones thought that it peaked in the option before. So everything we've heard so far is the high pitch in green there, so here's a lower one. And lastly, for key, we found that the major key was perceived as more healthy than the minor key. We've heard the major key, so here's the minor. We didn't see any significant trends for smoothness or dynamic. Up next, we looked at whether or not participants associate specific instruments with specific types of wellness. We gave participants 3 broad wellness categories of cognitive, emotional, and physical energy, and then a list of instruments and asked them to assign each instrument to a type of wellness. As examples for instruments here we have a trombone, and then voice. And once again, we found trends. Participants associate specific instruments with specific types of wellness. Cognitive energy, they wanted to be represented using a piano or a flute, so here's a flute. They wanted emotional energy to be on violin or the voice, so here's violin. And physical energy should be on trumpet or guitar. As a warning, the synthetic trumpet is not the nicest sounding thing, so yeah. All right, so moving on from that one. We found that while these trends exist, some level of personalization is still required. For our 52 participants, we generated 39 different models. If everyone was following these trends perfectly, there'd be 1 model. And if there were no trends, there'd be 52. So there's some level of personalization that's required, but also some level of generalization that can happen. As an example of this, here is what sounded healthy to our very first 2 participants. So you can see that they both followed some trends and deviated from others, but despite communicating the same message, those sound very different. Lastly, we looked at whether or not the music models can generalize to melodies that have more lines, essentially more complicated. So musical songs can have more than just 1 line or voice within the song, and do these models generalize to these more complex melodies? As an example of what I'm talking about, here's a scale with 3 instruments playing at the same time. And a song. So if you pay attention in each of those, there's 3 pianos being played at all given times. What we found was the transition from 1 line to 3 lines changes how the melody is perceived. Specifically, the unhealthy option was seen as more healthy when it's a more complex melody. So that single line would be perceived as less healthy than this triple line. But when we go from 3 pianos to 3 instruments, there's no change. So our takeaways, first off, wellness data can be communicated through music. Some level of generalization is possible, but also some level of personalization is needed. Instruments could be used to represent specific types of wellness, and melodies should be kept simple to be better understood. Thank you. Sorry for running over there.
Hopefully you were entertained a little bit.
I was curious what the participants were gender-wise and whether there were any correlations between preferences for, say, women and feminine voices, higher pitch voices, and men and lower pitch voices.
Yes, so I don't remember the exact distribution of gender off the top of my head. I do know it's present in the paper. What I do remember is we looked at the effect of demographics on each of the musical features, and we found no relationship.
Hi, Andrea from Nokia Bell Labs. I wanted to ask you if you could say a bit more about the models that you've used, mostly to understand like whether they could fit on a small device or something like that. Like, can elaborate more on that?
Yeah, absolutely. So the modeling, it goes into depth in the paper here, so I'll try to be fast because I know I'm already over. But what we're doing is we took music from Google's AI called Bach Cococo, which generates music in the style of Johann Sebastian Bach. And basically, we recorded what participants said sounded healthy and unhealthy, and then taking their choice for healthy and unhealthy, we're kind of combining those different options to try to predict what they would choose. And then looking at which features kind of overrule the other ones. Yeah.
Thank you.
Of course.
I think we are a little bit short. Hopefully in the discussion. Thank you. Okay, the next paper is presented by